Okay, so there's a double F, so the first thing I'm gonna do is be like lol involution trick. So if I consider triple F, I get f of n plus 1, all plus 1 on one side, and on the other side I get f of n plus 1 plus 1. Oh, actually it doesn't look much better, honestly. Meh. Meh. Okay, fine. I mean, it's okay. Like, it's just... I don't know. Oh, if we let... Oh, never mind. Oh, wait, that's pretty good. So let's let GF... Yeah, Cocoart's observation. Let's let G equals like f of n plus 1. Then G is linear. With slope 1. So this is actually just equal to like... We're working in FP, right? Sorry, slope minus 1. So this is like C minus N for some constant C. Okay, well, okay, what if I put n equals f of m? Like, I still want to unnest the f's. Well, maybe I could just iterate it. Like, f of n plus 1 is c minus n. And then... Can I iterate it? I'm not sure. Let's just try some junk. So if I put in f of n... I'll put m so it's clear. So this is a true statement because I substitute n equals fn plus 1 and the inside is f of c minus m. That doesn't seem that much better. Fine. If the stream's getting more delayed, you can try refreshing it. Yeah, the chat is not delayed. Basically, the problem is the chat that you see on the video feed is like also from my broadcast. So the latency it takes to take the project my video onto like everywhere else in the world. Which other? Anyways, okay, yeah, the C equation is good. What can I do with it? Well, in particular, f is surjective, right? I really feel like I should just be able to run it over because I have f of c minus m is equal to... If I take f of both sides of this... Well, okay, f is surjective, so f is bijective because it's fp to fp. Surjective. So f is surjective, hence it's bijective. And now what? Test on. Okay. Come on, come on. One or the other. Yeah, that's actually cute though. That thing that it's like if it's surjective, it's injective because it's an FP functional equation. I don't think I've had to do that before. Uh. Oh, actually, I think it's better to say. Sorry, it's not just F is. It's this G is linear. Oh, hang on. Okay, sorry, I changed my mind. F of n is linear. That's the important thing. The triple F is linear. It's equal to C minus n. For some, sorry, this is actually a different constant C, right? It's like C minus n. Oh, we'll be consistent, right? C minus plus 1 minus n. Why is G linear? Because it looks really dumb. It's literally because G of n plus, like the equation says G of n plus 1 equals G of n plus 1. Also, shit, is it? Sorry, it's plus, isn't it? Why did I think it was minus? Is the domain C or FP? We changed the domain to FP, like... yeah. Okay, well, okay, what did I do? Okay, what did I do wrong? People are upset at me, I did something wrong. F of n. This is G of n all plus 1 is G of n plus 1, right? Am I a crazy person? Please, it's minus 1. Wait, is this okay? Did I screw something up? I think this is right? Oh, I misread the original problem. Oh no, okay, I see. No wonder everyone's telling me to stop. Oh no. Alright, let's try that again. Oh shoot, that actually breaks the thing we were trying to do. Oh no. No! Oh no. I misparsed the original. Oh, that's horrendous. So can I still salvage this? I don't think so, right? This linear thing. God, that's so sad. That's the saddest thing I've heard all day. It's one of those days, I'm telling you. I thought maybe things were gonna be fine because like the Geo went okay, but we're back to everything being a disaster. Oh no. Okay, alright. I have an idea. What if I move the plus 1 over and then take f of both sides? Is that gonna do anything? I don't think this will do anything. Yeah, I don't think that helps. FF of n. Well, you can unwrap the right hand side a little. It's like f of. What is it? N plus 2 minus 1. I don't even see why it's bijective anymore. Like, I don't see a reason the function must be surjective. surjective. Oh no, sorry, yeah. Okay, sorry. This function is obviously surjective because like f of n is like f of n plus 1 minus 1. Written this way, I pick whatever I want in the range, so the range is closed under minus 1, hence surjective, hence bijective. Okay, fine. Yeah, that's fine. We still at least have that. The only saving grace. Okay. Can I use that at all? F to the 4n plus 1? This is getting more and more desperate. So if I unwrap it the other way, this is like f to the 4th n plus 1. This was... yeah, yeah, we can try that now, right? Does that help? This is just desperate. Like now, okay, so we had the FFF and we had FFFF, and now let's do FFFFF. So f of n plus 2 minus 2 is equal to f of n plus 2 minus 2. It's unclear if this is helpful at all. Or do I want to move the plus 2 over before? Wait, maybe I move the plus 2 before I do that, right? Because I feel like these plus 2s are running into each other. Okay, so if I do that, FF, alright, and then I can unwrap the F one more time, and I get f of n plus 3 minus 1. And on the left, what happens? F to the 8n plus 2. Is that correct? Is that actually what I get? Excuse me! Excuse me! What the heck? Okay, I see a pattern here. We now have f to the 2 to the k n plus k is equal to f of n plus k. Why is this helpful? I have no idea, but... Alright, what does this do? So f is periodic with like a period. F is periodic with period 2 to the p. I don't see how this is at all useful. Well, actually, hang on. F is no, hang on. So f to the hang on. F to 2 to the EP is okay. For this is true for every integer e and n. Every positive integer e. And then so f to the okay, so what is the GCD of 2 to the p rp minus 1 across all integers r? Sorry, why did I change it to, let's keep using e. So this GCD across all e is literally just 2 to the p minus 1. Okay, so that's not very helpful. So all, actually, it says something. All periods divide 2 to the p minus 1. Hang on, no, hang on. It's Wait, hang on. I think I confused myself. I got very excited for a moment. It's not 2 to the e to the p. It's 2 to the p times e, right? No, wait. No, it is e times p. What? Doesn't period divide p, or am I high? I'm just confused. No, so if you have a permutation on p elements, the period does not have to divide p. In fact, it probably doesn't divide p unless it's a cycle. So, I mean, this solves the problem if... It's a GCD of a bunch of numbers. Yeah, the period divides 2 to the p minus 1. Which is... I mean... I don't know what to make of that. So this solves the problem for p equals 2, 3, 5, 7. And 11... Wait, hang on. Hang on. What's the smallest... The smallest prime divisor... Oh, the smallest prime divisor of 2 to the p minus 1. Well, sorry. Any prime divisor of 2 to the p minus 1 is necessarily 1 mod p. And in particular greater than p. So... all fixed points. Well played. Very well played. Wow. Wow. This is Grant Yu's problem? My opinion for the quality of this problem is that you should have sent this to TSD, is my opinion. My opinion on difficulty is like, why did you put this as 4? If this is the intended solution, why is this 4? Like... There's a graph solution? Okay, then it's fine. Yeah, that makes more sense. Because I was like, if this is the intended solution, I'm sorry, this is like not usable 1-4. Like... But it's great. I've never seen anything quite like this. How to get f to the 4? Yeah, so what happens is, once you have f squared of n plus 1 is f of n plus 1, what I do is I take f of both sides of that, and then parse it using like this. So here, this thing, if I put double f here, gives you f to the 4, and then here is like f of thing minus 1, and then like, shit, so you get there, and then you kind of repeat it. You take f once, you run it like double, and you know, you kind of keep doing that. Yeah, this is not even involution trick. This is like like I was joked about FFF and then like quadruple F and quintuple F, but we ended up doing like F to the 2 to the K, and then using the fact what happens is, forget the E. The E doesn't help here. Let me just clear it. What happens is that means the period of F, like as a permutation on P elements, the period of F is divides 2 to the P minus 1. For example, if P equals 11, then like F to the 2047 is, yeah, forget the GCD. Yeah, F to the 2047 is like a fixed point. So you're like, okay, what are the prime divisors of 2047? And you realize, wait, the smallest prime divisor of 2047 is 23, still bigger than 11, and actually that's true for any prime P. If a prime divisor is 2 to the P minus 1, why is that the case? Because if you take, 2 has order P, is the reason. Like, if 2 to the P is 1 mod a prime Q, then 2 mod Q has order P, because it doesn't have order 1 and P is prime. Not primitive proof is the wrong word. It's just 2 has order P. Yeah. Yeah. It's almost certainly not primitive, actually, I think.